So we're here at the example table, and in this video we're going to find the zeros of the function sine of 2x minus cosine x. So just a reminder, the zeros of a function are the values of x for which f of x equals 0. So we set this thing equal to 0 and solve for x. Now a good strategy to take when you're not quite sure what to do with this is to see whether you can rewrite it as a times b equals 0, where a and b are somehow simpler than what we have here. Because if a times b equals 0, then either a is 0 or b is 0. So let's see what we can do here. This first page will just be some scratch work. If we want to rewrite this, well, we have plenty of ways to do that because we're looking at trig functions. But one thing that I hope jumps out at you is the fact that what's inside the sine is different from what's inside the cosine. And very often if we want to simplify or rewrite, we want these things to be the same. So let's see what we can do with this. If you remember, one of the trig identities says that sine of 2x is 2 sine x cosine x. So we can rewrite f. So f of x, instead of sine 2x, we have 2 sine x cosine x, and then minus the original cosine x. We now have two terms with a cosine, so we can factor that out. So f of x is cosine x times the quantity 2 sine x. That's what's left from this first part without the cosine. Take a cosine out of this, we're just left with minus 1. We want to set this thing equal to 0 and then solve for x. So that means that either this first term, the cosine x, is 0, or this second term is 0. The second term, so let's just do a little work here. 2 sine x minus 1 equals 0. Move the 1 to the other side and divide by 2. We get sine x equals 1/2. So where is cosine equal to 0? Remember that cosine is, well, let's see, cosine of this angle here, it's the ratio of the adjacent side over the hypotenuse. So cosine is going to be 0 when this adjacent side has 0 length. That's true when the angle is 90 degrees, or in radians pi over 2. It's also true if you rotate that 180 degrees, or by pi, so you're at 270 or 3 pi over 2 when the angle is sticking straight down. In other words, when it's straight up, cosine is 0. When it's straight down, cosine is 0. So this thing is 0 when x is pi over 2. Or if you add pi to that, you get here, 0 again. Add pi again, you're back up. Add pi again. Keep adding pi, you're just going to stick straight up or straight down. So pi over 2 plus any integer multiple of pi is going to make cosine of x equal to 0. Now what's going on with sine? When is sine 1/2? Well, sine is opposite over hypotenuse. So we want this to be 1, this to be 2. We don't need this side length here, but let's fill it in just to be thorough. This side length is root 3. This is a 30, 60, 90 right triangle. This is one you should know. This angle here is pi over 6. That's the 30-degree angle. It's the smallest one because it's opposite the smallest side. So sine of pi over 6 gives us 1/2. Well, just like before, if we start here and rotate all the way around by 2 pi, we're back where we started from. It's a different angle, but the same position. Do it again by 4 pi, 6 pi, whatever. So this thing, we get pi over 6 plus 2n pi. Right, that's going to give us sine, plugging this in for x is going to give us sine of x equals 1/2. But if you reverse this triangle, or take the mirror image, then we have 1, 2, and now negative root 3. The only thing that changed is the root 3 to a negative root 3. The sign is still the same. It's 1/2. This angle here is 5 pi over 6. And again, start at 5 pi over 6, rotate all the way around by 2 pi, all the way around by 4 pi. You're going to be in the same position, so you're going to have the same sine value. So 5 pi over 6 plus 2n pi. These are our solutions. So let's see. Let's write this up nicely. So, gotten rid of our scratch work. We want to solve for 0 equals sine 2x minus cosine x. First thing we did was rewrite sine 2x as 2 sine x cosine x, and then minus cosine x. We then factored out a cosine x, so we have cosine x times the quantity, 2 sine x minus 1. So this means that cosine x equals 0, or sine x equals 1/2. So x, cosine, remember, gave us pi over 2 plus n times pi, where n is any integer. That comes from cosine. Sine gave us 2, so or x equals pi over 6 plus 2n times pi, or x equals 5 pi over 6 plus 2n times pi. And all of these are for any integer n. And that's our solution.